Subchapter 4.5.3 Transmission heat gain. Transmission heat gain inside a space can be gained from the external sources and internal sources such as the partitions, internal walls, ceilings, and floors. The transmission heat transfer rate can be obtained using the equation of Q dot transmission equal to U times A times delta T, where U is the transmission coefficient from table 9, A is the area of wall or glass, and delta T is the temperature difference between the outside air and designated inside temperature. Transmission heat gain from the external sources. We are going to consider all glass area despite they are directly or indirectly exposed to the sun. The value will be taken for the glass vertical from table 9 external walls. However, for walls, we only going to take wall area that not exposed to the sunlight. The value for the transmission coefficient U can be obtained from table 9. Meanwhile, for the transmission heat gain from the internal sources, it may be contributed from the partition, internal walls, ceilings, and floors. Again, ceiling is only applicable for intermediate space. The term heat flows up or heat flows down are referring to the movement of heat based on the driving force of heat. We know that heat moves from high temperature region to low temperature region. For example, for a ground floor design space, the temperature of the ground will be lower than the condition of the space. Therefore, the heat will flow from the design space downward across the floor to the ground. Thus, we are going to take the value of heat flow down if the unconditioned space is above the design space, while heat flow up is when the unconditioned space is below the design space. For our analysis in MEC351, the infiltration effect will be neglected since we are going to assume the design space is perfectly insulated. Section B representing the Q dot transmission. Once all the values have been determined, we can obtain the total for section B.